rocket of a certain mass is at an angle theta away from the vertical with a force applied at the bottom of the rocket. The rocket has a centroidal radius of gyration of L meters and a length L. Find the acceleration of the center of mass and the rotational acceleration. To find the acceleration of the center of mass, first, break up the forces in the x and y components. In the x direction, the equation for the forces is the force applied is times the sine of theta is equal to the mass times the acceleration. Solving for the acceleration in the x direction, you get the force applied times sine of theta over the mass. The sum of the forces in the y direction is the force applied times cosine of theta minus the force of gravity is equal to the mass times acceleration. Solving for the acceleration in the y direction, we get the force applied times cosine of theta minus the force of gravity of the mass of the rocket. To get the acceleration, square the acceleration in the x and y directions, add them together, and then square root them. For the rotational acceleration, use the center of gyration to find the mass moment of inertia, which is the mass times the centroidal radius of gyration squared. If you take the sum of the moments from the center of gravity, you can ignore the moment produced by the force of gravity, and so the equation becomes the force applied time the moment arm is equal to the mass moment of inertia times alpha. The moment arm is the length of the rocket up to the center of gravity, which is L times sine of theta. Solving for alpha, the equation becomes the force applied times the length L times sine of theta over the mass moment of inertia, which is also equal to force applied times the length L times sine of theta over the mass times the radius of gyration squared.